Hi everybody, welcome to this workshop on building a front-end for smart contracts. Today we are going to talk about a front-end using Viem. We are going to explore Viem concepts. We are going to see what we need to track when building a front-end, even when we're using AI. And we are going to then go to the code and connect a web front-end to NeonVM. And use Viem to read balances and send Neon transactions. Of course, nowadays we mostly use AI LLMs to create front ends for our contracts, for our apps that we build on the blockchain. And of course, there is nothing wrong with that. The only thing is that if you know the frameworks, the front-end frameworks behind the MCP, for example, documentation that you pass to your LLM, then you're going to get a much better results, and it's going to be just so much easier to bug fix and to know what's going on when nothing works. So today we are going to look into those front-end basics, the fundamentals that are going to help you become a better front-end builder or just a better vibe coder. Even if you're vibe coder a front-end for a blockchain app, you are going to become a little bit better at knowing what's going on. So to start with, let's look at this new front-end framework for Ethereum smart contracts called Viem. So we are going to go through the core concepts and see how exactly Viem helps us to connect to the blockchain. And of course, we are going to connect to NeonVM. Now, there are three core concepts in the Viem framework, and these are client, chain, and transport. Client, for example, this is the first part that we are going to explore. This is basically the interface that gives us TypeScript functions to talk to the blockchain. It decides, you can say that it decides what actions we are allowed to perform. And it's Viem kind of separates the clients into three types based on what they are allowed to do. First of all, there is a public client. It's used only for read-only operations. And you can read data from the blockchain using a public client, using functions like, for example, name, symbol. We are going to also use total supply function. And public client doesn't need a wallet because it doesn't require user permission and doesn't sign anything. So it's only for the read-only functions. Then it has a wallet client, and this client is used for everything that demands state changes and demands user approval, therefore. So these are actions that modify blockchain state. They require signature, authorization, and these can be such actions as, for example, requesting to connect the wallet address, switching the networks, signing transactions, sending transactions, of course, for transfer, calling contract functions that basically changes state, minting tokens, so everything that needs our approval. And then there is also a test client that is used only when working on a local environment, on a local development blockchain, for example, when using Hardhat or Anvil or something like that. It allows you to basically simulate blocks, impersonate accounts, and run tests locally. And we are not going to use test client in this tutorial because we are going just to connect to an DevNet RPC URL and use the public client and wallet client for that. This is the first concept that you need to know about because we are going to create particular components and use functions referring to these concepts. So the next important concept is, of course, chain. And when using Viem, what we mean is that the chain defines which blockchain network we are communicating with, and we are going to pass the chain ID, the RPC URL, the native currency, and the block explorer. So there is nothing new here. These are pretty basic components that we need to create for interacting with the chain. So we are going to provide this chain configuration to the client so that it knows where to send the requests, and so that wallet knows which network it should be connected to. So nothing new here. And then the third concept is the transport. And this is something that you might not be familiar with, but basically this concept transport defines how requests are physically sent from our code to the blockchain network. And Viem supports several types of transports. The first is HTTP. It sends requests over HTTPS, and this is the most common and most reliable method. We will use this one for reading, for public reading from Neon. Then the second is WebSocket transport. This is used when you need real-time updates or event subscriptions, for example, when listening to live contract events. Today, we're not going to use it. Then the third is custom transport. This is used when connecting through a browser wallet, such as MetaMask, for example. And also there is a fallback transport, which means that we can provide multiple RPC providers. And if one fails, then Viem automatically tries the next one, which is very convenient. So three important components. Again, these are the client, the chain, and the transport. And again, to summarize, the client defines what we can do. The transport defines how the request travels, which transport it uses, and the chain defines which network we are connecting to. So what does a front-end developer usually need from a contract to allow for a UI to connect to the blockchain and to read and write state from the contract and back? Now, to build a front end for any smart contract, we don't really need to know Solidity. We don't need to be able to create smart contracts ourselves. We only need the information required to call the contract from the UI. And there are four pieces of information we must have. The first, it's, of course, the contract address. This is the location of the contract on the blockchain, and we are just going to pass the contract address in, for example, our env file, environment file, and we are going to be able to send transactions or read the state of this contract when we know its address. Then we need the contract ABI. This is basically the description of the functions inside the contract, and we are going to create a separate ABI file in our app, so that it can tell our front end what functions basically exist in this contract and how we can call them. Then we need the functions. We must know the specific functions of the contract that our UI will interact with. For example, there is usually a function for symbol of the token, decimals, total supply, balance function to read the balance of the address, a minting function, a transferring function, and so on. So there is important to note here that we don't really need to know all the functions that are used in the contract. all the contracts for the app we are creating, only the ones that are used in our UI. And finally, we need the RPC endpoint, the network to which we are going to connect. And for this tutorial, we are going to use Neon DevNet. Neon RPC can be found in the, of course, documentation. You can go, there are links that lead you to chain list where you can just click connect wallet and connect to Neon Viem DevNet. This is the link where you can find this chain list. And there you can copy the RPC URL and also the chain ID of Neon Viem DevNet. So now that we know what kind of things we need to look out for in our front end, we can go ahead and create a Next.js app. Just open your terminal and write this command. Okay. So we are creating a Next.js app. Yes, so we are going to use the recommended defaults and use TypeScript, install React and Next dependencies. Okay, the app is successfully created. Now we can open it and see what it has. So this is the structure of the app that we created. It doesn't have anything it doesn't really contain the actual front end yet, but it created a default page, for example. All the files that we are going to add, we are going to add here in the app folder. And for this project, we are going to create just the most basic web front end for connecting a wallet and sending some Neon. So first, in this app folder, we are going to create a client file and to start with a wallet button file. So let me just we can click new file and call it client.ts. And why do we need this client file? Basically, this file is going to have a wallet client connection and a public client connection. Wallet client, as we've discussed before, for sending transactions and signing messages for everything that changes state of the blockchain, and public client for reading data from the blockchain. So let me go back to another screen and just show you what we are going to need here. Oh, yes, of course, we need to install Viem. So yeah, let's just go back. Okay. All right, so now we can go ahead and create our first file. As I've told you before, we are going to use this file to connect wallet client and connect public client. So This is the code we are going to paste into our client.ts file that we created in the app folder. And so first of all, the connect wallet client function, basically what it does is it creates a wallet client. First, it checks whether the window.ethereum exists, which is a provider injected by a browser wallet like MetaMask. And if it's not available, we throw an error telling the user that no wallet is installed. So basically, first we check if MetaMask connection is possible. And if a wallet exists in the browser, then we create and return a Viem wallet client. So here in the chain, we are going to specify to use our neon chain so that it selects a correct neon network settings, which we are going to specify later. So it will take neon chain ID and neon RPC URL. And in the transport, we are going to tell Viem to send requests through the connected wallet using this custom provider. And the client will be used for any actions that require wallet permissions, such as getting the address or sending the transaction. Now, about the public client, we already know that we use it to read state. So basically, we are going to need it to get balance or read the contract data. So first here, we check whether a wallet provider exists in the browser. And if a wallet is available, we use it as the transport. That is going to keep the public client aligned with the wallet network and help when switching chains. So in that case, we return a VM public client using the neon chain configuration and the wallet as the transport. So this is the whole code where we imported the wallet client and public client from Viem and defined our neon chain, adding the chain ID, name, currency symbol, and RPC URLs so that the frontend knows how to connect to which network it can connect. And then again, we are telling the frontend where it can find the chain to which it should connect and to pick the RPC URL. And here is that wallet client connection and the public client function. So there you go. In the client.ts file, we once again defined our chain and told the frontend how it can connect to the chain for writing state and for reading state. For writing using wallet client and for reading using a public client. Now we are going to create a component that handles the connection logic to our Web3 wallet. And this is going to be a wallet button. So wallet button, we import our two client builders, one for wallet actions and one for reading from the blockchain. And now we define the component with the wallet button function. So this function is going to create a wallet button component that we'll place in our page. And inside it, we create state variables. There are basically two pieces of local state address, which is going to store the user's wallet address, and balance that will store the balance of that address on Neon. We are going to initialize the address as null and balance as 0. And next, we are going to create a handle click function, which will run when the button is clicked. Basically, when the button is clicked, it should trigger connection to the wallet, fetch the address, and read the balance. So inside this function, we have this check that the wallet is connected to the Neon chain. And if it's not connected, we ask the wallet to switch networks. So then we get our clients. Wallet client is defined as a connect wallet client, and public client defined as connect public client. So this is how we basically create two Viem clients. One is going to be used to talk to the wallet, and the other to read from the Neon RPC. And then we request the wallet address. So we call getAddress on the wallet client, and it's going to prompt the wallet to connect if it isn't already, and it returns an array of accounts. So we take the first one, and we read the balance using our public client, and of course get balance. And this is going to send a read-only request to the Neon RPC and return the Neon balance. So, and finally, we update the UI state with the set address and set balance. And basically, that is the whole logic here, all in this wallet button. Okay, now let's move on. And the next button we are going to create is the send button. So this is the send button that we are creating to send a particular value. We are just going to hard code it this time without allowing any input from the front end. Here we define the send button component, and again we need to handle the click, what happens upon the click, and this handle click function again runs when the user clicks the button. It connects to the wallet and sends a transaction. But first, we of course need to ensure the wallet is set to Neon, ensure Neon chain selected, and then we create a Viem wallet client and request the user's wallet address. So this will trigger a wallet connection pop-up if the user hasn't already connected. And here we validate the recipient and throw an error if the wallet isn't connected to Neon. And then if the wallet is connected to Neon, we call the send transaction. And we here are going to require the address of the sender, the address of the recipient, and the value. We, of course, display the transaction details and include the transaction hash later so that the user can check it in the Explorer. So these are basically the only two components that we are creating for this front end. The wallet button that allows us to connect to the user's wallet. And again, here we are using the wallet client that we looked at the beginning, and the public client. Again, the wallet client is for writing data and public for reading data from the blockchain. And when we create the any button, we need to handle the click action. So the same goes for a send button. We are not creating an input field for the user here, so we are only handling like the hard-coded value that is going to be sent. But still, we also need to handle the click when creating a button function, and we need to make sure that the correct chain is selected and that we are using a wallet client that gets us the address and then that allows us to send the transaction. Basically, to display these components in the UI, we simply need to add them to our page, and that's it. We are just going to create a couple of buttons and see if they work. So now we just need to go to terminal. Hello, terminal. And run npm run dev to check it out on localhost. And this is it. And this is the frontend that can be so easily created just with a couple of components. These are the two buttons that we created. One connects the wallet and one sends Neon, the hard-coded amount from our wallet to another wallet. That is, again, hard-coded actually in the app for simplicity. So let's try connecting the wallet. Okay, so this is the wallet that we connected. Okay, so we accidentally hard-coded the recipient to be the same as the sender. But anyway, let's just, send it. And this is also what I wanted to show you, a simple diagram of what happens when we send this transaction. We saw the send transaction function, which sends it from our created UI to a wallet client. Remember, we created and imported this wallet client that sends the transaction to MetaMask and then broadcasts the signed transaction to Neon RPC that can execute it then on Neon Viem and send a transaction hash right back to our UI. So once again, to recap, when you're using Viem, watch out for a wallet client, basically for the clients, and remember that whenever you need to read state, you need to use a public client, and whenever you need to write state, you are going to be using the wallet client. You need to define the chain, define the transport. Here we used a custom transport and an RPC URL. And then again, for things that you need as a front-end developer are just the contract address, the contract ABI, then the functions. For example, here we had a transfer function. And also, I think that balance off and total supply. And then you just need a network ID and an RPC endpoint so that your UI knows which network to connect to. Thank you so much for your time. Please have a look at Viem documentation to understand once again how it works, so that whenever you're going to create a front end for your smart contracts, you know when things go wrong, where to look, and what to be aware of. Thanks once again, and feel free to ask questions. Bye!